These are learning objectives for the next few lessons of work. This is the first video of two. You need to copy down all these learning objectives into your copy. The best thing to do would be to pause the video at this stage and copy these down. Thank you. Now let's look at limits. Where have we seen the word limit before? Speed limits comes to mind. And what does speed limit mean? It means we're approaching the outskirts of the town and we see the speed limit of 50 kilometers per hour. What does this mean? It means, or it should mean, that as we approach the speed limit, we need to slow the car down until it reaches the speed of 50 kilometers an hour at or before that sign. So this is the speed it's going to reach. That's the meaning of the word limit. It's the value that something is going to reach. Now let's consider the function y equals f of x, where f of x is equal to x plus 5. So what we have here is put simply that this is y is equal to x plus 5. Now clearly, just going back to first year and second year work, clearly when x is equal to 2 and we substitute it in, 2 plus 5 is going to be equal to 7. Now, what we're going to look at is we're going to explore the concept of what does it mean to have a limit, and the context of this, a limit when x equals 2 of y is equal to 7. Now, we intuitively know from above that as x approaches 2, then y approaches 7. Another expression for that is as x tends to 2, y tends to 7. So different ways of saying the same thing. What does that mean mathematically? Well, x is 1.7. What's y going to be? Well, y is going to be 6.7 because we're adding 5 to it. If x is equal to 1.8, y will be equal to 6.8. So as x approaches the 2, then y will approach the 7. And that's what we mean by the words limit. This means we can say as x tends to 2, then y will tend to 7. We're now going to look at notation and examples of where limits is used. So first of all, LIM is short for limit. That's obviously x. The arrow stands for the word tends to. So this says basically, find the limit, find the value of this expression as x tends to 5. Now we've got 4 examples here. You can pause the video at any time, any line, just to help you work it out. So I can go fast, but you just need to pause and copy down as you go. Let's do it line by line. Let's look at the first line. So what have I done in the first line? Oh, it's very simple. I've literally replaced the x by 5 in each case. So here we've got 5 plus 5 over 5 plus 7. Here's 5 minus 5 over 5 plus 5. Here's 5 plus 5 over 5 minus 5. And here's 5 squared minus 25 over 5 minus 5. And when we do that, we get the following answers. There's no problem with this. It's 10 over 12. 0 over 10, no problem with that. Now, there's a very real problem with this one and a very real problem with that one. Because in mathematics, we're not allowed to have the 0 on the bottom of a fraction. It's not allowed. Simple as. So the problem is, how do we solve it? Because technically when we're saying let x tend to 5, we're not actually, it doesn't have to reach 5. There could be a value that it tends to, and we can avoid this problem with 0 on the bottom. But let's just explore it one more line. The first one cancels down to 5 over 6. This one cancels down to 0. This one, division by 0, it's not allowed. So we say it's not defined. And the one at the end is 0 over 0. Moving down here, because it's not defined, we say in these circumstances there is no limit. There's a definite number on top, there's a definite zero on the bottom, so this is a big no-no. And that's the something you need to learn. So we will explore what happens when the bottom of a fraction approaches zero. Let's have a look. So what we have here is we've got the bottom is a 1. So now what we're going to do is we're going to look at making the bottom 0.1. And what actually happens here is that 10 divided by 0.1 is 100. So moving that on, 10 divided by 0.01, well, that's equal to 1,000. Again, moving it on. And we've now got a situation here where 10 divided by this incredibly small number gives us an incredibly large number. Now what we say here is as the denominator approaches the zero, the value of the fraction is getting very large indeed. This leads us to say that the bottom of the fraction, as the bottom of the fraction tends to zero, the fraction tends itself to infinity. And that's really important because we can now go back up to above the red line and we can now say that 10 divided by 0, the limit, there is no limit because infinity can never be reached, but the limit is infinity. So division by 0 is not allowed. We say it is not defined. We say it's not defined. There is no limit. Now, the issue is what happens when it's 0 over 0? And the problem with that is also not allowed. But the problem is we've got a 0 on the top and on the bottom. And so there is a method to find the answer if the limit exists. And we're going to explore that method on the next page. So looking at number 4 from the previous page, and this part can very often be done in our heads, but when you put 5 in, you get 25 minus 25, which gives us a 0 on top, and 5 minus 5 gives us the 0 on the bottom. And when you get a 0 top and bottom, then you have to follow the stages outlined in this bullet pointed list. You need to pause the video at this stage and copy down that bullet pointed list underneath this example. I will continue on the other side. So what's the method for actually solving this problem? Well, the method for solving this problem is you have to factorize fully top and bottom. It's absolutely essential that you factorize top and bottom fully. So you've got the limit as x tends to 5, and when you factorize the top, you should spot that you have the difference between two squares. The square root of x squared is going to be x, which we write in both boxes. The square root of 25 is going to be 5, which we write at the end of both brackets. And the final part of factorizing the difference between two squares is you put a plus in one bracket and the minus in the other. The division symbol goes in, and now you've got x minus 5 on the bottom. We have a common bracket, top and bottom, so we can now cancel the bracket top and bottom, and when we do that we can then progress to the next line, and the next line is now going to read the limit as x tends to 5 of the expression x plus 5. And now when we sub it in, we get 5 plus 5, and we get an answer which is equal to 10. So far from having 0 over 0 as not being defined, we've actually got the answer is 10. Now you need to get into your heads what the concept of limit actually is. What it's saying, it's not saying it's equal to 10 when x equals 5. It's not saying that. What it's saying is that as x approaches 5, this expression will approach 10. What happens when it gets to 5, we're not particularly interested in at this moment in time. All we're interested in is what it appears to happen. So as x approaches 5, then the expression x squared minus 25 over x minus 5 approaches 10. Yay, lucky us. Even more examples. Now, just bear with me. If I ask you to cube the value of 3, then you should get 3 cubed is 27. So we're going to get, on the top of this fraction, we're going to get 27 minus 27, which is 0. On the bottom of the fraction, 3 minus 3 is going to be equal to 0. So, you can work it out, and we've worked it out, and, in our heads, whatever, we've subbed it in, whether it's or on the calculator, we've subbed it in, and we discovered we've got a 0 over 0, which means we have some work to do. And the work is simply this. You have got to learn that when you get a 0 over 0 situation, then the only method for solving this is by fully factorising the top and the bottom. Now the top on the left-hand side, I hope you spot that, is the difference between two cubes. So I'm just going to remind you what the difference between two cubes actually is. There is a formula, and the formula it's back in September we did this. So there is 2 brackets, and to get the first entry in the first bracket, the method is quite simple. We have to cube root this expression. So the cube root of x cubed, well, it really couldn't be simpler. It's going to be x. And the next thing we have to do is we have to cube root this second term. We have to cube root this second term, and we write the cube root in here. And the cube root of y cubed is y. Now, for those of you who can't remember how to do the difference of 2 cubes, I will carry on. What I'm saying to you in words, you might write down and take the point of learning. It as quickly as you possibly can. So what we're going to be doing here is we're going to be squaring it. So when we square the x, we're going to get x to be squared. And then what we're going to be doing is we're going to take this y and we're going to square it, and then we're going to get a y squared at the end. Now, I am not writing in the instructions. You can write those in yourselves. So there is the y squared. Now, how do you get the middle term? Well, to get the middle term, it's the product of the 2 terms in the first bracket. So it's the product of the 2 terms in the first bracket. So we've got the product of these 2 terms is the product of x and y. So we end up writing x on y. Now we need to worry about the signs. There's only one minus sign, and whatever the sign is here is always the sign you put in here. So if that was a plus here, you'd be putting a plus in between the x and the y. There's only one minus sign, so therefore the other 2 symbols must be a plus. So that's a quick reminder. So now let's do it for x cubed minus 27. So let's do it for x cubed minus 27. So I'm going to talk you through this process again. So the first thing we do is we have a small bracket and then a slightly larger bracket. I'm going to cube root the x cubed. I'm going to get x. I'm going to cube root the 27. The cube root of 27 is going to be 3. 3 3s are 9, 3 9s are 27. Cube root of 27 is 3. How do I get this term here? I square the first one. I'm going to square the first one, so therefore that's going to be x squared. How do I get the term in the middle? It's the product of these 2 terms, so it's going to be 3x. How do I get the term at the end? How do I get the term at the end? I square the 3. So 3 squared is going to be equal to 9. And there's only one minus sign, so there it is, and then the rest are pluses. So now I've done the traditional working out over on the right hand side. I can come back over here and move it on. So we've got the limit as x tends to 3 of x cubed minus 27. We now know it's equal to x minus 3 on x squared plus 3x plus 9. And then that's going to be all divided by x minus 3. And of course what we have now is we've got an x minus 3 in a bracket on the bottom, and we've got an x minus 3 in its own bracket on the top, and it's a multiplication situation, so therefore we can cancel them out. So we've now got the next line where we've got the limit as x tends to 3 of this new expression, which is now going to be x squared plus 3x plus 9. And then what we do is we substitute in the value of x, and when we substitute the value of x in, we're going to get 3 squared. Well, 3 squared is going to be equal to 9, plus 3 threes, which is going to be equal to 9, plus 9. And since there is a definite value, which is 27, then that's the answer. The limit of the original expression is equal to 27. And that's the end of that particular problem. Okay, so we've now got the last one, and I think you can guess what's going to happen. If we substitute in 3 here, we're going to into the x squared. If we substitute 3 into here, we are going to get 9. 9 minus 3 is 6, minus another 6 is going to be 0. X squared is 9. 2 9s are 18. 18 plus 3 is going to be 21. Take away 21 will give us 0. So once again, either using the calculator or by just doing it in your head, we're going to end up with a 0 over 0 situation, which is not defined. We cannot be certain as to know what's going on. So what we're going to do now is we're going to factorize the x squared minus x minus 6. Now we're going to factorize the x squared minus x minus 6. We now know that the number in front of the minus x is going to be 1, so it's going to be minus 1x. The number at the front is 1, the number at the end is minus 6, so we're going to do 1 times minus 6, and we're going to get the answer is minus 6. We're now going to work out all the factor pairs of minus 6, so 1 comma minus 6, 2 comma minus 3. And we're looking for a factor pair that will add up to the middle number, and the middle number is minus 1. So we're looking for a pair that will add up to minus 1, and we found it. So because we found it, we can now go back up here and go to the next line and factorize it. So we're going to split the minus 1 into plus 2x minus 3x minus 6. We're now going to factorize in pairs, and we've been doing this since second year, so you should be well up to doing this yourselves by now. So the common factor for the first two terms is x, leaving us with x plus 2. We cheat. We know we've got that right. We put x plus 2 there. We're looking for the common factor up here. The highest common factor is minus 3. Double check. Minus 3 on x gives us minus 3x. Minus 3 on plus 2 gives us minus 6, so we know it works. So now we can finish off. Common factor is now x plus 2, so that's in the first bracket. And in the second bracket is going to be x minus 3. So we can come back down here and we can begin to write the next line. The limit as x approaches 3, and the top is now going to be x plus 2 on x minus 3. Now we need to fully factorize the bottom. This is the method that is open to us, so we need to fully factorize the bottom. Okay, same as before, we're going to take the first number, which is 2. We're going to multiply it by the n number, which is minus 21, and we're going to get minus 42. And we need to find the factor pairs of minus 42. We need to be aware that the number in front of the x is a plus 1. And now the factor pairs of minus 42 are going to be 1 and minus 42. It's going to be 2 and minus 21. It's going to be 3. And how many 3's go into 42? It's going to be minus 14. Fours don't go in, 5s don't go in, 6 does go in, and it goes in 7 times. Now when we add 6 and minus 7 together, we get minus 1. But what we're looking for is we are looking for the Now what we're looking for with the factor pairs is the factor pairs that will add up to give us plus 1. So we are looking for the factor pair that will give us plus 1. Now this factor pair doesn't work because when we add them together it gives minus 1, but it gives us a clue as to what it could be. So don't forget, if you change one sign, you change them all. So the 6 becomes a minus 6 and the minus 7 becomes a plus 7. When we multiply these two numbers together, it still gives us 42. But when we add them together, we get the 1. So we can progress this quadratic on. So that's now going to be 2x squared minus 6. Now that 6 has been used to split the 1x. Becomes minus 6x plus 7, that's where the plus 7 comes from, plus 7x minus 21. We're now going to fully factorize in pairs. There's a common factor of 2, because 2 goes into 2 and 2 goes into 6. There's a common factor of x, so we're taking out a common factor combined of 2x. That leaves us behind 1x, because 2x on 1x gives us 2x squared. 2 goes into 6 3 times, so we've got minus 3. Quick check, need to make sure we get this right. 2x on minus 3 is minus 6x. We know it's fully factorized, we know it's correct, so we can progress. So this has to be 1x minus 3. We write that immediately, and then we go looking to see what the common factor is for plus 7x and minus 21. And it is going to be plus 7. Still check it. 7 times 1x is 7x, so we know we're on the right track. So the next line is, I'm going to write that line out just one more time because it's looking a bit cluttered up there. So just writing it out there. Thank you for your patience. Now, the common factor, as you can clearly see, is the common factor, as you can clearly see, is the x minus 3. That's the common factor. So we take out x minus 3 as a common factor, and we're going to end up left with 2x plus 7, which goes inside the other bracket. And that allows us now to come back over to the original problem and slot back in that factorized version, which is x minus 3 on 2x plus 7. And once again, you'll notice that we have a common bracket top and bottom, and therefore we can cancel that common bracket out, and now we can progress to the next line. So we've got the limit as x tends to 3 of x plus 2 over 2x plus 7. So what we're going to do now is write back the same thing we did right back at the beginning, is that we're going to substitute the value of 3 in. So on the top line, we're going to get 3 plus 2, which is going to give us 5. And on the bottom line, we're going to get 2 on 3, which is 6, and 6 plus 7, which is going to be 13. Now, normally I would show the working out, but hey-ho, I'm running out of space. So just to be a bit purist, I suppose I could have done the working out over here. So x plus 2 on top becomes 3 plus 2, and that's going to become on 2 on 3 plus 7. 3 plus 2 is equal to 5. 2 on 3 is going to be 6. 6 plus 7. So that's equal to 5 over 6 plus 7 is 13. That's a definite answer. Listen to my language. So as the limit, as x approaches the limit of 3, the expression up above, this expression here, is going to tend to 5 over 13. Thank you.